This program is a huge source of national pride, and China has invested billions into it.
China runs one of only two places that humans can live in orbit, the Tiangong space station.
China is on track to become the world's top technology superpower, with a grip on military, space, robotics, energy, the environment, biotechnology, artificial intelligence, advanced materials, and key quantum technology. Furthermore, recent news reveals that China has a stunning lead in 37 of 44 crucial emerging technologies, as Western democracies lose a worldwide research output battle. But now, China has built something so advanced that it has the potential to change everything. What is going on? Join us as we walk through the top 10 current developments in China that will impact everything. Type 3 carrier. China's newly developed Type 3 aircraft carrier boasts a truly flat-top design, setting it apart from its predecessors that were based on Russian models. Unlike the current Chinese carriers, which employ ski-jump catapult systems limiting their range of fighter and bomber launches, the Type 3 is designed to be as large as the American Ford-class carriers. Notably, it will feature an enhanced launch and recovery system known as catapult-assisted takeoff, but arrested recovery, a capability previously seen only on US and French carriers. Additionally, the Type 3 incorporates improved defense mechanisms, utilizing advanced electronic warfare systems to disrupt and spoof incoming missiles. Anticipated to enter service by 2025, this carrier represents a significant advancement in China's naval capabilities. DF-17 Hypersonic Boost Glide Missile. The DF-17 Hypersonic Boost Glide Missile stands as a likely contender to become the world's first operational hypersonic weaponry. This advanced missile possesses the potential to fly at altitudes that evade radar detection, presenting a challenge to existing radar systems. Furthermore, it's poised to outmatch US anti-missile defenses like the Patriot and THAAD systems. The DF-17's capabilities pose a potential threat to US military assets in the East Asian region, with the capacity to achieve speeds ranging from Mach 5 to Mach 10 during its gliding phase. The missile boasts a range spanning between 1,100 and 1,600 miles. The DF-17 is characterized by its exceptional maneuverability and precision. It's worth noting that this missile could eventually be armed with nuclear capabilities. DF-41 ICBM and carrier-killing missiles. The DF-41 Intercontinental Ballistic Missile, ICBM, is undeniably formidable and scary, representing China's most advanced ICBM. Equipped with the capability to carry 10 multiple independently targetable re-entry vehicles, MIRVs, this missile's 10 nuclear warheads are capable of reaching the United States. Notably, the DF-41 is versatile, capable of both road mobile and silo-based launches. China's recent construction of around 100 new missile silos near Yumen, coupled with the deployment of the DF-21D and DF-26B anti-ship ballistic missiles, underscores its strategic approach. These anti-ship missiles, known as carrier killers, are strategically positioned along the South China Sea coastline, serving as anti-access area denial assets. With approximately 200 DF-21 mobile launchers and missiles supporting 1,300-pound warheads and an effective range of 910 nautical miles, US naval ships in regions like the Taiwan Strait face increased vulnerability. The DF-41 ICBM stands out as the most potent among these weapons, with the DF-17 Hypersonic Boost Glide Missile mentioned above as the second most significant. As American nuclear strategists consider Chinese first or second strike capabilities and intentions, these missiles become pivotal considerations. Beijing's strategy centers on ensuring its nuclear forces can withstand a first strike, emphasizing the use of hardened silos and mobile wheeled launchers. CH-7 drone. China's newly revealed CH-7 drone has raised eyebrows due to its striking resemblance to the US Navy's X-47B. And this resemblance might not be coincidental. While the Navy took a step back from prioritizing combat drones after encountering resistance from US pilots, this strategic shift potentially allowed China to gain a technological advantage. Much like the X-47B, the CH-7 is a stealth drone designed for carrier-based operations, capable of entering contested airspace, conducting surveillance, and engaging in combat if necessary. Should the CH-7 perform even remotely as well as the X-47B, it could grant China the capability to target US forces on land and disrupt aircraft formations without risking the lives of their own pilots. This could be a significant game changer, especially considering that China's aspirations in both military and civilian aviation have been hampered by the scarcity of pilots. Golden Eagle CR-500. Limited information is available about the Golden Eagle CR-500 at this time, but it is identified as an unmanned helicopter designed to carry air-to-ground missiles. Early reports suggest a flight endurance of around 6 hours and a maximum payload capacity of 4 missiles. If successfully developed, projects like the Golden Eagle CR-500 could provide China with the capability to engage US forces on land using compact naval vessels. This technology could potentially replace the need for large-scale land deployments for reconnaissance purposes or waiting for ground teams to secure potentially occupied territories. Instead, utilizing smaller ships equipped with these unmanned helicopters, China could swiftly survey islands and engage targets they identify immediately. Now, let's shift our focus to 5 of China's most recent achievements and advancements in the realm of space exploration. Tiangong Space Station. China's involvement in space exploration traces back to its nascent stage in the early 1950s, marked by the inception of rocket and satellite technology development. A pivotal moment arrived in 1970 with the launch of China's first satellite, Dongfang-Hong-1. While China commenced its celestial journey later than the advanced endeavors of NASA, its recent accomplishments have been truly remarkable. Central to these achievements is the impressive Tiangong Space Station, a testament to China's rapid ascent in space exploration. China's initiation into space exploration dates back to the early 1950s, when the nation embarked on developing rocket and satellite technologies, though it entered the scene later than NASA's sophisticated projects. The Tiangong Space Station, aptly named Heavenly Palace, became a symbol of China's cosmic ambitions. Completed on November 29, 2022, with the successful docking of the Miengchan model to the Tianhe core module, the station's construction took 1.5 years. It now stands as the 3rd permanently crewed space station in orbit, following the International Space Station, ISS, and Mir, boasting the distinction of being the largest and most complex. Engineered to accommodate a crew of up to 6 individuals, the Tiangong Space Station incorporates diverse scientific and research facilities. Additionally, the station is anticipated to contribute to commercial ventures like space tourism and telecommunications. The completion of the Tiangong Space Station signifies a momentous achievement for China, positioning it favorably to compete with the United States and Russia in the future landscape of space exploration. China's inaugural quantum communication satellite, the Shijian-21, was launched on October 24, 2021, through a Long March 3B rocket from Xichang Satellite Launch Center in China. The primary objective of this satellite was to evaluate and validate space debris mitigation technologies. The launch, although a significant accomplishment, was shrouded in secrecy, with China refraining from divulging any information about the satellite's mission prior to liftoff. Following the launch, China's state media agency, Xinhua, disclosed that the satellite was part of an on-orbit service, assembly and manufacturing initiative, OSAM. In December 2021, the Shijian-21 satellite executed an impressive feat by successfully docking with the non-functional Beidou 2G2 navigation satellite. The Beidou 2G2 had been launched in 2011, but failed to reach its intended operational orbit. It was consequently maneuvered into a graveyard orbit. However, its presence still posed a risk to other satellites. In a notable display of capability, the Shijian-21 utilized its robotic arms to securely grasp the Beidou 2G2 and skillfully relocated it to a higher graveyard orbit. This achievement significantly contributes to reducing the potential for collisions between satellites and other celestial objects. China's expanding growth is accompanied by ambitious aspirations, and one such endeavour is the nation's intention to deploy a substantial constellation of over 100 microsatellites, each outfitted with X-ray telescopes, for observing cosmic phenomena in deep space. Spearheaded by the Chinese Academy of Sciences, CAS, this initiative is known as the Space-Based Multi-Telescope Array, SMTA project. The constellation will comprise compact satellites designed to surveil the celestial sphere through the lens of X-ray vision. X-rays, a form of potent radiation emitted by exceptionally energetic and tumultuous celestial entities like black holes, neutron stars, and supernovae, will be the focal point of SMTA's observations. Unlike conventional X-ray telescopes, the SMTA's interconnected microsatellites will collectively detect X-rays emanating from these cosmic entities, which are often too faint or transient to be captured by traditional equipment. The resulting capability will empower scientists to scrutinize these enigmatic phenomena in an unparalleled level of detail, facilitating deeper insights into their origins and evolution. Undoubtedly, this compilation would be incomplete without highlighting the momentous launch of the Long March 5B, which stands as China's most substantial and potent rocket. Its inaugural flight occurred in November 2016, ushering in a new era of space capabilities. Characterized by its capacity to transport sizable payloads to orbit, the Long March 5B achieved yet another milestone on July 24, 2023, when it took off from the Wenchang Space Launch Center, situated in Hainan, China. On this mission, the rocket effectively conveyed the Wenchang space station module into its designated orbital trajectory. A notable derivation of the Long March 5, China's preeminent rocket model, the Long March 5B stands apart with its configuration featuring a core stage and 4 supplementary side boosters. Distinguishingly, this rocket boasts an innovative design, wherein its principal and most substantial stage also functions as the upper stage, responsible for deploying the payload into its intended orbit. Noteworthy in its dimensions and weight, the Long March 5B's initial stage exceeds 23 tons. This uniqueness led to a remarkable distinction, the heaviest rocket stage ever to re-enter Earth's atmosphere without controlled guidance. The Tianwen-1 mission marked a significant chapter in China's space exploration journey, setting off on July 23, 2020 from the Wenchang spacecraft launch site. This landmark venture encompassed an orbiter, lander and rover collectively aimed at comprehensively studying Mars. Carried into space atop a Long March 5 heavy-lift launch vehicle, the spacecraft embarked on a 7-month odyssey that culminated in its insertion into Mars's orbit on February 10, 2021. The mission carried a multitude of scientific aspirations, including delving into Martian surface geology, deciphering its internal composition, detecting traces of water's past and present presence, and appraising the planet's atmospheric conditions. A pivotal moment arrived on May 14, 2021, when the lander and rover named Zhurong disengaged from the orbiter and descended to the Martian surface. Zhurong's touchdown marked China's maiden achievement of landing a rover on another celestial body, with 6 scientific instruments in tow, including an advanced radar capable of penetrating the Martian terrain to identify water ice. Zhurong embarked on its mission. Undoubtedly, the Tianwen-1 venture shines as a remarkable milestone in China's ambitious space program, with its intricate fusion of orbiter, lander and rover capabilities and its capability to orbit, land and deploy a rover with one mission, a feat previously unprecedented. The mission, anticipated to span at least a Martian year, around 687 Earth days, bears a price tag of approximately $2.2 billion. The wealth of knowledge gleaned from this endeavour has been unparalleled, yielding valuable data encompassing images, videos, and detailed insights into Mars's atmosphere and soil composition. Considering these strides in both military and space exploration in China, what are your perspectives? We welcome your thoughts and insights in the comments section below.